The city of Viridian has a population of 2,000 and is growing by 200 people each year. The surrounding rural area has a population of 1,000 and is growing by 450 people each year. If these trends continue in a linear fashion, when will the population of the rural area outgrow the city population? So I'm going to think about my given information and how I could represent that in a linear format. So I'm going to let X here represent the number of years from this initial population that we were given, and let my Y represent the population. So if we start with the city, so I'm thinking about the form y equals mx plus b, my slope-intercept form for a linear equation. In this form, m tells us a rate of change, we call it our slope, and b is an initial population or a starting point. So for the city, we're told that the rate of growth is 200 people per year and that the initial population was 2,000. So we can represent that as an equation. The population is equal to 200 times x, the number of years that we've been looking at, plus the initial population of 2,000. We can do that same thing for the rural area, thinking y equals mx plus b. We're told that the rate of change is 450 per year, and the starting population is 1,000. So we can represent that as y equals 450x plus 1,000. So in each of these, x represents the number of years since we started counting. Y is the population at that particular year. So we're interested in the population of the city. When will that match the population for the rural area? And then we're going to look at when does rural actually start to outgrow. So at the initial value, the city is larger than the rural, and at some point they're going to be equal to one another, and then the rural will start to be larger from there. So since we're looking at setting these populations equal, y represents the population. So for the city, y is equal to 200x plus 2,000. The rural, the population is 450x plus 1,000. So this gives us a linear equation with just one variable x, the number of years. This tells us when these populations will be equal. So I'm going to start by getting all my x's on the same side of the equation. So you can subtract 450x from both sides. So we have negative 250x plus 2,000 equals 1,000. So since my x's are all on the left, I'm going to go ahead and subtract 2,000 from both sides. So I have negative 250x equals negative 1,000. Dividing both sides by negative 250, we get that x is equal to 4. So remember, x represents the number of years. So from these initial populations we were given, after 4 years, the populations of the city and the rural area will be equal to one another. When you get beyond 4 years, this is when the rural will have a larger population than the city. So anytime after 4 years, the rural population will be larger than the city. So at exactly 4 years, the populations will be the same. Anything after 4 years, the rural population will be larger from there. So we start by thinking about the given information as a rate of change and an initial value. We can use those as an m and a b in a slope-intercept setup. Once we have that for the city and the rural, since we're looking at when those will be equal to one another, we can set each of those equations equal, solving for x to find the time when they're equal, and then when the rural will be larger from there.